about Jupyter Notebooks. Jupyter Notebooks and their usage is kind of holy war topic. Some people love it, some people hate it, but it should not be that black and white. Why? Tania will tell us.
Yeah, thank you, everyone. So as I've been introduced, I'll talk about Jupyter Notebooks and whether they are our friends or our worst enemies. The reason why I'm here is because I work as a research software engineer, which is also like a research engineer or a data engineer. I live in that ambiguity area that Alejandro was mentioning before. And for 2 years, more or less, I was working in Open Dreamkit, which is a European project around virtual environments for researchers and data scientists. And it was all about developing new tools and new things around the Jupyter ecosystem. And also so much of that was understanding how all the people were using Jupyter Notebooks or Binder and other tools. So a lot of the things that I'm going to be talking about is about all that work that I've been doing and how we've been helping others to use or not to use Jupyter Notebooks, even in some cases. So I imagine that a lot of you are familiar with Jupyter Notebooks, but we're going to take an intermediate dive into what they are and why there is so much fuss about them. If you do a quick Google search, you're going to find that Jupyter Notebooks are rich documents that have code as well as rich elements like plots or equations or other artifacts, interactive artifacts. And this is a reason why they become so popular, because also they have shifted the paradigm of the literate programming, in which a person generates a script or a program that is more human readable and not just computer readable. So you can imagine that this has pushed a lot the narratives and compelling narratives on how people and how scientists and researchers tell their stories, how they disseminate what they're finding, and how they disseminate their data. So if you've seen notebooks or you've worked with notebooks before, this is pretty much the standard image or the standard representation that you will have in your mind. Something starting with some sort of documentation or an explanation, and then the codes and the outputs all together in a seamless document. But if we go a bit further down, we can then split this into parts. The notebook document itself, that is nothing but a self-contained JSON object. And it's self-contained because it contains, it has inside all of the metadata that tells you what interpreter you were using, what version of, for example, if you're using Python, what distribution you were using, the file extension, the version of NVConvert that you were using underneath. It also captures the data that you're working with, the code as you imagine. Also, if you have LaTeX output in sense of MATLAB equations or pure markdown or HTML elements and any other generated objects that can be the plots and things of the such. On the other hand, we have the notebook app itself, and this is the client-server side. This is the actual app that allows you to serve, create new notebooks, edit your notebooks, and run the content of it. Generally, this is formed by a kernel, and the kernel is, again, the abstraction that allows you to edit and run your code, your code. And because the notebook document has become so popular, there are many interfaces and many apps that we can use now to interact with them. The most popular now being the traditional Jupyter Notebook, now evolving into Jupyter Lab, Microsoft Azure Notebooks, Google Colab, Stencil Lab, and Interact, and all the subdivisions inside the Interact family. And they will look a bit different and similar at the same time. So this is, for those of you that are not familiar or have not used it, the new interface of Jupyter Lab that will eventually replace the old Jupyter Notebook. And this has much more of an IDE integrated feel. You have better access to the console and the notebooks. Instead of having to have 30 tabs and in your web browser, you can have everything in a much more intuitive way or intuitive display. Google Colab have, of course, their own flavor of notebooks app. What I find particularly interesting or particularly good about Colab is that you can try GPUs for free. So if you're doing some exploratory work, or you're doing any work before actually committing to giving your money to AWS or Google Cloud or Azure, you can request free GPUs using Colab. They natively integrate. And it's great if you're doing things with TensorFlow or things of the such. And then we have Hydrogen. That was the first iteration of Interact. So Interact, so that you can actually have interactive Python scripts and see them as if they were Jupyter Notebooks. And since then, many other things have evolved, like the actual Interact desktop or the VS Code integrations for Jupyter Notebooks. And I truly believe that the notebooks are awesome. I love the notebooks, and you're gonna understand the kind of love that I have for them throughout this talk. I truly believe that they're great because they're fantastic for prototyping. I imagine that so many of you as data scientists or people doing some sort of research use it mainly for data explorations, to generate models, to train models, and see the output straight away. And it also gives you a nice documentation. It gives you a very nice, understandable layout of what you're doing. So again, this is what a notebook would look like, and this is an example of LA Times. They do all of their analysis on their datasets or government data from LA using Jupyter Notebooks, and then they took it into their journalism platform to export, well, to pass it on to the general public. And if you notice, this is not Python, but it's R, and this is probably one of the best features of Jupyter Notebooks, that they are inherently polyglot. From the very beginning, when Fernando Perez envisioned this new abstraction, the whole name pointed out to Julia, Python, and R, pointing to the interoperability and polyglot abilities. And nowadays you have over 80 kernels, so that means you have over 80 different programming abstractions that you can use. So you can interact with different programming languages in a single document. And there is this amazing example from Fernando Perez again. If you follow the link at the bottom, you can actually go and see and run and execute the notebook. So in this example, he starts with Python to do a traditional analysis, import your libraries, start doing exploration and some plotting. But then, I don't know, if you get to a point in which another programming language is probably the best tool, then you can switch over to that context. In this case, he uses Julia because Julia is really good with very big amount of data, and a lot of people in neuroscience are using Julia because they're really good. It's a really good programming language. But then if you hit a point where you're not getting performance, the performance that you would need or the speed that you would need, you can even switch to a programming language that is not dynamic, but a static programming language like Fortran or C++ or even Scala to go into functional programming paradigms. And you can do all of this seamlessly and pretty much effortless inside a Jupyter Notebook. And this is fantastic for so long. If you wanted to do something like this, you would have a script per programming language and then have to do some crazy makefile or bash orchestration to get these interactions across these different kernels of these different programming paradigms. Also, you can go further, and then if you're doing dissemination of your results, you can use the same notebooks to generate other artifacts that are not code, but for example, presentations or slides. And things like Rise from Damian Avila can transform your Jupyter Notebook into complete interactive presentations. So as you're going over, you evaluate the code. I think Alejandro was using it for his presentations. And you can also have extra interactive components. And this means that not you're only running your code and evaluating and printing and extracting data frames, but you actually can have a user interaction in how this data is manipulated. And you can think of using date pickers or sliders or radial buttons if you want to go into something a bit more data frame oriented. For example, if you're working with pandas, you can use QGrid. And these widgets give you full interactivity with your Jupyter Notebook in the form of you can start filtering your data, do some manipulations in the data frame, have two data frames side by side. There are other widgets that allow you to have 3D volumes in the same in your notebook. Also, there are other libraries that you can use, for example, to analyze MRI or scan images and do the actual rendering and change the visualizations to highlight specific parts. And probably one of the nicest things that IPython 7.0 and Evolve brings is that now they support async I/O. So if you were wanting to do async programming or start working with concurrency and things of the such, and you were lacking this interface to Tornado and things of the such, now you can do it. And because it's all natively in the IPython kernel, it should work with any of the abstractions. Call it Jupyter Notebooks, Colab, Jupyter Lab, Colab, Interact, or any other abstractions or apps. And the ecosystem is so big. I think this is something that often gets very diluted. We think about Jupyter as being the Jupyter Notebooks and forgetting that solely the project Jupyter has over 72 repositories, and those are tools, Jupyter Notebooks, and there are other extensions that help you have a much better workflow as a data scientist. And it has a very, very engaged community. It's a very active community. You have hundreds of contributors generating this amazing extension. So now you have your vanilla notebook, and you can have other extensions that allow you to change the font, that allow you to change the color or the syntax of your notebooks, and do things like formatting your code. Or this is a super nifty extension that allows you to add snippets. So if you regularly use NumPy or SciPy or Pandas, you can have readily importable snippets, and that will save you a lot of time. You can save your own snippets. Let's say that if you're doing a lot of NLP tasks that is going to follow the same format, or you're going to always import the same libraries, you can save your snippets and have them readily available for all your kernels. And it's all good fun, and it's all nice, and we have all of these beautiful things, and I do love the notebooks. But they're very painful to work with. I work a lot with, as I mentioned before, with data scientists and researchers. And my job, to a certain extent, is to understand how people use these tools to better support them and make their work more reproducible, more robust, more sustainable. And that notebooks also make my work really, really hard. I mentioned that there is a vast ecosystem, but sometimes it is just too vast. Every single week there is something new going on. I just can't keep up. And I would say that myself, I am a very embedded person inside a community. I work with Jupyter developers. I develop for Jupyter, and I still can't keep track of what's going on. So every week, I have to go onto Discord, I have to go into Twitter, onto a lot of mailing lists, and try and understand what people are doing with Jupyter. It's a good thing, but also it makes it hard to have a good understanding on what the best practices are. And probably one of the things that annoy me the most of the notebooks is a lot of things are hidden. And we have things like, oh, well, I should get this result. I have this so many times, especially when I'm teaching, or when I have someone that has transitioned from R into Python or from Julia into Python, and are using now the notebooks. And like, well, have you run the cells in order? Well, should this matter? Yeah. And you see things like this in which you can start with a very simple example and say, I'm going to create a function that calculates the sum of a number with itself. So then if you do sum of 2, then it should return 4, but then you evaluate 4, whether the result of that function was 4, and you get an annoying false. And you think, well, what's going on? You have to do a much deeper introspection of what is actually happening on there. And if you're an experienced user, this is going to be very obvious. So is it obvious to you what is happening there? Okay, is it obvious? You think you know what's going on. You wouldn't dare say you have an idea. And this happens so often. So when you go into the REPL, or when you go into your IPython traditional kernels, you see what you're doing, you get the output. So there is no way in which the order of your commands or your functions or your calls is altered. But there is this thing called history magic, and we have these magic commands in notebooks that you need to know that they exist so you can use them. That is called history. So it prints the history of what I was doing, as it is called. So you can see that the execution numbers that are on the left of my cells are not continuous. So obviously there is something between cell 2 and 3, 2 and 4 that happened, but I don't know what it is. And so probably I made a mistake and evaluated again, and then I returned that, and that's why I'm getting that false. But if you don't know that that's how notebooks behave, then you wouldn't be able to understand it. It will take you so long to debug it. And I even forgot that it was only 1% symbol before history, and I typed twice, and you can see it. And I forget things. Then when you have also these other abstractions of the Jupyter Notebooks, it's not only the notebook itself that has its own quirks, but the apps or the environments themselves have quirks. So these persons say, well, using Collab is easier if you know that when you press restart runtime, then it is only the Python interpreter that is being restarted. But then if you were doing other processes, or were calling bash, or were doing other intermediate stuff, that is still there, that still persists. So you can't restart that unless you reset all the runtimes. So this brings another extra set of problems that you can imagine. And something that annoys me the most is I spend so much time reviewing code. Data scientists will come and say, hey, Tania, I've done this absolute beautiful model, and it's going to revolutionize fintech and everything. And they send me a link to their own repository, and it's Jupyter Notebook, and all I can see is that their execution count went from 18 to 48. And then I get this beautiful blob that could be anything. So it doesn't play nicely. Jupyter Notebooks don't play nicely with our traditional version control systems, because these are used and designed to work on plain text. So when you have something that is a different abstraction, they just don't work. And then you're kind of forced to change your workflows. You're forced to adapt your workflows. And then we start seeing, because of these weird behaviors, we start seeing a lot of people start doing even weirder things to go around this. And you start seeing people thinking, well, I want to define a class. Why can I not define a class across different cells, but them still being the class? And you start seeing Does that even make sense? In a normal script, you would have your class, you'll have your modular, your script, or your code is modular as possible, but in the cells, you have to structure your code in a different way. Then people start using Jupyter Notebooks for everything. Say, well, now that I've done my exploratory analysis and my plots, I'm going to create my package that is a Jupyter Notebook, and I want to then import it into another Jupyter Notebook or into another script or something. So we start seeing very, very weird behaviors, and this was part of my job, understanding what weird behaviors people were having when using Jupyter Notebooks. And then again, there is this thing of importing Jupyter Notebooks as modules and how you test Jupyter Notebooks, and then the solution is to convert from Jupyter Notebooks into scripts and test the scripts, or having the input into and an output and test the output. So you start creating anti-patterns. And well, a lot of people in research still use high-performance computing traditional clusters, because those are the systems that they have. Universities pay, I don't know, millions of dollars and euros and pounds to maintain that, and Jupyter Notebooks don't play nicely with that. You can't create your Jupyter Notebook and submit it to a cluster and expect it to return what you should be getting. So then you have either two options, transforming that again into a traditional script, or supporting a Jupyter hub on your HPC cluster that is nothing but a Jupyter interface to the cluster. So you start creating a lot of anti-patterns. And then people start talking about them, they get annoyed, they say they like it, but then they hate it, and nothing makes sense. And they're like, well, it's not surprised, because most of these problems are all about context. A lot of people are going to say that Jupyter Notebooks encourage bad habits, hinder reproducibility, generate anti-patterns or anti-patterns, and some others. Just say, just burn them, just get rid of them, just kill them. And I know that Jake likes notebooks, but he still says that they're not very good for reproducibility, that we should enforce reproducibility. And something that also kills me is when I open a repo and I have 50 untitled PyConBy, because how do you enforce people to stop doing that when your computer or your system doesn't complain that you have 25 untitled notebooks? So I have a lightly opinionated approach, and all comes again to the context and identifying when and how to use the notebooks. If I have my data scientists or my researchers and say, hey, Tania, I have this, can we take into this model into production? Or I have this awesome package that will change how everyone in the world is going to do data science, and forget about TensorFlow, this is a thing, and they give me just Jupyter Notebooks. I can't work with that. Nobody can work with that. They're great for exploratory work, for narrative work, but probably not the best work for building libraries to creating production-ready objects, at least not on their own. If you're looking at dissemination, you can start using other side projects inside the ecosystem, inside the Jupyter ecosystem. So I don't know, if you're disseminating, for example, your paper, you can share it with Binder and a Jupyter Notebook. That ensures that all the dependencies are there. Your readers don't have to download, install, and bother. And it's accessible to everyone. You can even use it for free. The fact that you have Jupyter Notebooks doesn't mean that you cannot test them. You can use tools like MBVal that allows you to validate notebooks, and it's like a regression test in which every cell is a test and it is run under the hood, and if the cell doesn't return the same saved state or the same saved output, then you can count that as a failed test. If you want to have reproducible environments, use something like repo to Docker, which is again under the hood library that works under Binder. find ways to make your life easier. Version control is an absolute nightmare, but then there is this library called mbdime that you can add as a extension to your Jupyter Notebook, and this is much more understandable than having that execution cell change 4848 and the horrible blobs. It can also show the differences between plots. So even if you only changed it, it was changing the color of your scatter plot or your lines, that will be captured and reflected. And delegate responsibilities. If you are willing to use Jupyter Notebooks in production, use other tools like Luigi or Airflow or Azkaban. Delegate tools that responsibilities to tools that are reliable and consistent. And again, choose the right tooling, because people are going to say, I know that Netflix uses notebooks for production, but again, the notebook that they use is an artifact that is being orchestrated, and it's being run by workers and schedulers, and it is only used to parameterize and generate the reports. And that works, because in that case, you're not relying on someone using the same specific order. It is just run in a programmatic way. And then just use common sense. Ensure that your notebooks are fairly linear. If you start doing a lot of crazy things and then sharing kernels among notebooks and then having to look at how to import a notebook inside a notebook, it's time to switch to something else. It's time to switch to a script. If there is something that you're reusing and calling all the time, yes, you can create the snippets, but consider using a more traditional software engineering approach in generating your libraries. Test them. Test your notebooks. Test everything. And in the spirit of Python, short and simple is better. Try to keep things concise. If you're generating 100 plots, if you are manipulating 50 data frames and you're clogging up your notebooks, try to split it into comprehensive smaller pieces and have perhaps 5 notebooks instead of 1 notebook. Consider using something like Jupyter Book that will get your 5 or 6 or 7 notebooks and condense it into a book that has hyperlinks between them. And again, it's all about context. Whenever you find yourself working and trying to work around all of these different behaviors of Jupyter Notebook, ask, who's going to consume this? Am I expecting this to go into production? Do I want someone else to use my new method to revolutionize the area of data science? How many parts are there? How many moving parts are there? If it's easier to go down traditional software engineering approaches, use them. And am I reinventing the wheel? Am I going to create an unsustainable, unmaintainable, complex new tool? Then probably you have to go back to the basics. Thank you.
Thank you. So, anybody wants to ask some questions about Jupyter? So, nobody wants to argue that common sense is much better than cargo cult? Guys, you're making me feeling bad. Okay, so let me ask a question on my own in this case. So, what are the most common problems that you face when people misuse the Jupyter?
Code never being verified. So people will execute their cell, then go to another cell, go back, revisit, and eventually they'll get to a result that they think it's acceptable or what they're looking for. They save the notebook, and then if I go and audit the notebook and run everything, I won't get the same result. Or eventually, because they don't have proper, as any code, if they don't have proper dependency management, things will just blow. They'll just blow when there are so many components and things of such. They just become really, really unsustainable.
Okay, and let's just imagine that I'm kind of data scientist and I understand that I do everything in Jupyter because that's what I did. But I had your speech and I understood that I'm doomed. What should I do to become better?
Oh, you're not doomed. I wouldn't say that you're doomed. But I think there are a lot of resources out there, and sometimes it's going back to that basics. And when you have developed something, well, some of the things that I do is we do a lot of exploratory work, and then once a notebook is working and we're getting the outputs, transform it into something that can be more easily maintained, that can be more easily verified, more organic. And you can start by, I don't know, learning how to write classes properly or how to make your code more interoperable. Rely less. For example, if you're developing models, more than likely you do need a visual element like Matplotlib or Plotly, unless you're actually working on the visualization part of things or dashboards, for example. So then it makes it so much easier to bundle everything in a more traditional script. And it'll make you better because you'll have to use best practices eventually. You'll have to focus more on the code and the actual abstractions of your code, instead of sometimes hacking your way until you get the result that you're expecting. That is something that I have found.
Thank you. By the way, how many of you uses Jupyter right now? And how many of you use only Jupyter to write code? It's okay. So, thank you, Tania. That was a last